Hi to everyone, welcome to VLN-Academy. Today we are going to see some of the most important and multiple statement based questions in strength of materials. Let's start. So this is our first question. In a tension test on mild steel on universal testing machine, at which stage of the test should the extensometer be removed from the test specimen for its safety? Okay, so uh, for this we have to see the curve for mild steel. Okay, so for mild steel, up to this is proportionality limit, then after it will be elastic limit, and up there will be an upper yielding point and there will be a lower yielding point. From here to here it will be yield, and after that it reaches ultimate point and it will breaks. So after this yield point, okay, this is upper yield point, this is lower yield point. From here to here it is a yield point. After that it will break at any time after reaching ultimate strength. So if it breaks, the extensometer attached to it may get damaged due to excessive strain of the mild steel. So to for not to not getting damaged by this extensometer, we will remove the material at yield point. Okay, next, second question, which of the following beams is an indeterminate beams? So this is, first of all we will see the what are determinate beams and what are indeterminate beams. First of all, determinate beams are where the degree of indeterminacy is 0. In this determinate beams, what are the determinate beams where degree of indeterminacy is 0? So those are cantilever beams. Okay na, cantilever beams. Next, simply supported beams and 3 hinged arches. Okay, 3 hinged arches, total 3. Okay, C is for cantilever, simple supported beam and 3 hinged arches. Next one is indeterminate beams. Okay, next is indeterminate beams. So for indeterminate beams, degree of static indeterminacy is not equal to 0. Degree of indeterminacy is 0. So what are indeterminate beams means? Fixed beams. Okay, first one fixed beam, second one continuous beam. Okay, continuous beam, and third one 2 hinged arches. Okay, first what are determinate beams? Determinate beams are cantilever, simple supported, 3 hinged, and indeterminate beams are fixed beams, continuous beams, 2 hinged arch. Okay, for this indeterminate, which of this is a indeterminate? The answer will be is continuous beam. Okay, continuous beam. So how we will calculate this is determinate beams and indeterminate beams? One formula will be there, that is m plus r minus 3j. Okay, m plus r minus 3j. If this m plus r minus 3j is equal to 0 means those are determinate beams. Okay, those are determinate beams. If it is greater than 0, then those are indeterminate beams. Okay, if this formula becomes less than 0 means that is minus value, those are called unstable structures. Okay, unstable structures. Okay, for this the answer will be continuous beam, option 2. And third question is, which of the following statements are correct? Okay, are correct. So as we all know that brittle material is strong in compression but weak in tension. So statement A is correct. Okay, and for statement B, what they have given, they are discussing about ductile material. So in ductile material, okay, ductile material, so it is is strong in tension but it is weak in shear. Okay, ductile materials are weak in shear. Okay, so the statement B is wrong, so answer is only statement A is correct. Okay, answer for this option J. Next, fourth question. Okay, the following statements are associated with the stress strain diagram for steel. Okay, stress strain diagram for steel. For small values of the strain, the relationship is linear straight line and the stress is directly proportional to strain. This behavior is valid until the stress reaches the proportionality limit. As we all know that stress strain diagram for this is up to proportionality limit. Stress is directly proportional to strain. So is discussed correctly. So statement 1 is correct. Okay, statement 1 is correct. For the statement 2, if the stress exceeds the proportionality, what happens if stress exceeds its proportionality limit? It becomes an, what it becomes, increase more rapidly and the slope of the curve decreases. Okay, now stress begins to increase more rapidly and slope of the curve decreases. So both the statements will be right. Okay, both 1 and 2 statements are right, because after exceeding the proportionality limit of the stress limit begins more and increases more rapidly and the slope of the curve will decreases. Okay, slope will be decreases. Okay, next, fifth one. So consider below statements with respect to Poisson's ratio. What here he was discussing about? He was discussing about Poisson's ratio and identify the correct answer. Okay, identify the correct answer. Statement A. When the deformation of a member is within elastic limit, it is found that within elastic limit, it was found that lateral strain to longitudinal strain is constant for a given material. If it is in elastic limit, elastic means it will regain its original shape. There will be no deformations in any material. It will be as it is after uh, uh, within elastic limits. So if it is in within elastic limits, it will not undergo any deformations and there will be no Poisson's ratio. Okay, so within the elastic limits found lateral strain to is constant. He was saying constant. So right, when the deformation of a member is plastic in nature, it found the ratio of line is constant. How it will be constant? If the member is in plastic in nature, if it is in plastic nature, the material will not be in original condition. It will undergo some deformations in lateral direction or longitudinal direction. Originally it was like this, it will undergo like this after deformation. So there will be, it will be not constant, it will undergo some changes. So what it is, option statement 2 is wrong. Statement A is right and statement B is wrong. So what is the option? A is correct, B is incorrect. So answer is option C. Okay, option C is the answer. Next, sixth question. So next items consist of two statements. There consist of two statements. We have to justify whether it is right or wrong. Okay, statement 1. Okay, statement 1, the tensile strength. Okay, the tensile strength or ultimate strength is defined as the highest value of engineering stress. Ultimate strength. Okay, tensile strength is discusses about ultimate strength. So statement 1 is right. For ductile materials, okay, ductile, the tensile strength correspond to that point at which necking starts. Okay, so for ductile materials only necking will starts. For brittle materials there will be no necking occurs. Okay, both the statements are right. So the answer is option B. Both statement 1 and statement 2 are individually correct, but statement 2 is not the correct explanation of statement 1 because it is not properly explaining about the statement 1. Okay, so it is talking about necking point and it is talking about ultimate strength point. Okay, next, seventh question. Okay, for seventh question, as per the theory of simple bending, the value of Young's modulus of elasticity. What is the value of Young's modulus of elasticity? So value of Young's modulus. This is an IES previous year IES question. Okay, previous IES question. So the answer will be, it is Young's modulus will be same in both tension and compression. What will be the Young's modulus? Okay, theory of simple, what is the Young's modulus? 2.1 into 2.1 into 10 to the power of 5 Newton per mm square, both in tension and compression. Option B is the answer. Okay, next, ninth question. So ninth question, this is important question. Ductility depends on. Okay, ninth question, ductility depends on. Where the ductility depends on? Ductility depends on temperature. If temperature increases, there will be the iron material or steel material will expand. If you use these experiments, you will see in your child activities, in science activities. So depends on ductility, depends on temperature, and it does not depends on size. Okay, it does not depends on size and does not depends on loading time. It only depends on temperature. Along with temperature, ductility also ductility depends on, along with temperature, it is also depends on grain size. Okay, grain size of material. Okay, grain size of material. What are the impurities? Based on impurities, it will ductile, because based on what do you say, based on impurities, the material will behave. Okay, so ductility is nothing but deforms. Okay, it is in nothing but a plastic deformation under an external load applied. Okay, so option for this is only one is the answer. Depends on temperature, grain size, impurities. Okay, these are the three conditions. Next, 10th one. Okay, 10th one. So this is all this is matching question. So modulus of rigidity means what? Shear stress to shear strain. So for P it is 4. Okay, modulus of rigidity means shear stress to shear strain. Poisson's ratio means changes lateral strain to longitudinal strain. Okay, it is transverse strain. So that is Q is 3. Change in lateral strain to longitudinal strain. Okay, next, Young's modulus is normal strain, R is 2. Okay, Young's modulus R is 2, and bulk modulus is volumetric strain. Okay, bulk modulus is dependent by K. Okay, so S is 1. 4 3 2 1. 4 3 2 1. Option D. D is the option. Next, which method is used to obtain yield point? Which method we will use? Usually offset method. This is not SER, that is offset method. Okay, offset method. Okay, common offset is at 0.2%. Common offset is at 0.2%. Next, for a plane strain problem, number of non-zero stress components will be 4. This is direct question and standard question, important. Okay, for plane strain problem, number of non-zero stress components will be 4. Okay, next, the plastic response of a material to a compressive force. Okay, just wait, I will increase the brightness. Okay, so the plastic response deformation of a material to compressive force is malleability. Ductility is plastic deformation, and ductility is for tensile force mainly. If a tensile force on a steel material, it undergoes ductile material. And if an compressive force acts on a metal, it undergoes malleability. Okay, so compressive force, it is malleability. For tensile force, undergo plastic deformation, that is ductile material. Elastic material will comes to its original position after loading. Okay, next, this is a steel rod with an area, cross sectional area 1250 square square, and 3 meter length, is suddenly subjected to an axial pull of 50 kilonewton. What is asking about suddenly subjected to means formula is stress to sudden. Okay, suddenly subjected formula is 2p by a. Okay, for this 2p by a, 2 into load 50 into his, there is units kilonewton. For kilonewton, kilo means 1000, 10 cube means 1000 by area. Okay, 1250 square. 0 gets cancel. Okay, 25 2 ja 5 ja 25. Okay, and this is 20 times, and this is 5 times, and this is 4 times, and this is 10 times. For 2 is 8, so 80 newton per mm square. Option A is the answer. Okay, so